Hello students, welcome back to the session. So in this session we will discuss what do you mean by oscillation and what are the different aspects of oscillation. So in the previous classes we will be learned about the rectilinear motion, that is nothing but the translatory motion. What do you mean by translatory motion? Means the motion of the object from one point to another point, okay, in a straight line is usually what we call it as a translatory motion, or it will be called as a rectilinear motion. And also we have studied about what do you mean by projectile motion, right? So projectile motion means throwing or projecting an object, okay, so from the horizontal by making an angle theta with the horizontal and with a certain velocity. So this is what we call it as a projectile motion, okay. And there are few other type of motion. For example, motion of an object in a circular path, motion of an object in a circular path, and orbital motion of planets, okay, orbital motion of planets, okay. In these two types, in the first two what we have said, that is a rectilinear motion and the projectile motion, so they are not repetitive, means they it is not, it cannot be repeated again, okay. So they are not repeated. But here what the examples that I am quoting now, that is one is your circular motion and another is the orbital motion of planets, so these are repetitive. And we have also seen that is in our childhood we will be playing on a swing, correct, swinging on a swing, okay. That is also what is it, repetitive motion, but it is little bit of different from that of your periodic motion of the planet or the circular motion, okay. So I am quoting one more example, that is swing, that is child swinging in a swing. I think in childhood everyone has played, okay. See, I am mentioning three different types of categories of motion. One, here we are saying that rectilinear motion or translatory motion and projectile motion, which is not repetitive. Hope you have understood. And we have another type of motion where we have the circular motion and orbital motion of the planets. Of course these are repetitive, okay. And I am telling you one more example, that is a child swinging in a swing, okay. So this is also a type of a motion which is repetitive, but it is quite different from the circular motion of the planet and orbital motion of the planet. So this swing, that is a motion of a swing, is little bit different from that of your circular motion and orbital motion. Even though both are repetitive, but there is a slight difference between what is your circular motion of the planet, orbital motion of the planet, and this swing of this one. Or we can quote one more example for a repetitive which is different from these type of motion. So that is nothing but a mass attached to a spring, mass attached to a spring and executing some motion, okay. Hope you know that. Suppose if I consider a spring which is attached to a rigid support, and if I load this spring with a certain mass, so what happens, it goes up and it comes down, goes up, comes down, goes up, comes down. So this is almost a repetitive only, and again different from your circular motion or orbital motion of the planet. So what is that something different of motion of these two examples and these two? So that is what we are going to study in this chapter, that is what we call it as an oscillation. So before going to oscillation, we need to what is that, know what do you mean by periodic motion, and what do you mean, what are the conditions for the body to execute periodic motion, and what do you mean by oscillatory motion, and what are the conditions, okay. So that should the body show to execute a oscillatory motion. So let us look into the periodic motion. periodic motion. So what do you mean by periodic motion? So a phenomena or a process or a motion which repeat itself at equal intervals of time is what we call it as a periodic motion. Understood? A process or a motion which repeats itself at regular intervals of time. So this is what we call it as a periodic motion. Now let us see some of the examples for periodic motion. Motion of Earth around the sun is periodic. That is, it takes 365 days to complete one revolution around the sun. Okay. So this is an example for periodic motion. Why? Because after this 365 days, again the earth starts to revolve around the earth. Okay. So therefore it is periodic. And one more example that we can quote for this periodic motion is pendulum clock, that is movement of a pendulum clock. So that is also a periodic motion. And we know that Hiiii comet, okay, which is having a time period of 76 years. So every 76 years once this Hiiii comet will repeat. So this is what we call it as a periodic motion. And heartbeat of a person, okay, so which is about 0.83 second. Okay, so this is what we call it as the periodic motion. So I will repeat it once again. Any motion which repeat itself at regular intervals of time, so such type of motion is what we call it as the periodic motion. And here we have quoted few examples. One is the motion of the earth or revolution of the earth around the sun, that is nothing but 365 days. After 365 days the motion will get repeated again by itself. Okay. Another type of periodic motion is your Hiiii comet, so which is having a time period of 76 years, and again heartbeat of a person is around 0.83 second. So these are the few examples, okay, so of periodic motion. So hope you have understood what do you mean by periodic motion. Now let us understand what is meant by oscillatory motion. Let us understand what do you mean by oscillatory motion. See, oscillatory motion means any body, if it moves to and fro repeatedly about a mean position, then that is what we call it as the oscillatory motion. So what is that? Oscillatory motion means if a body moves to and fro repeatedly, then that is repeatedly itself is called oscillatory motion. Okay, so I will repeat it once again. Oscillatory motion means if a body moves to and fro repeatedly by itself is what we call it as oscillatory motion about its mean position. So this is what we call it as oscillatory motion. Okay, now let us see some of the examples of oscillatory motion. So oscillation of simple pendulum. oscillation of simple pendulum. So what do you mean by simple pendulum? You have seen in your physics first year laboratories. So hope you know what you mean by simple pendulum. There is a small mass attached to a string, inextensible string, and which is suspended with the rigid supports. So that is what we call it as a simple pendulum, right? So there is a heavy mass, okay, suspended. So this is your heavy mass, and this we call it as a bob, okay, and supported, tied with the help of a string which is inextensible and which is tied to a rigid support. Now this is its mean position. Now if I drag this bob this side or this side and let it to get into motion, so it will set the to and fro motion, or to and fro motion is also nothing but called as back and forth motion. Okay, this will execute back and forth motion or to and fro motion. Okay, so this is an example for oscillation. So now let us look into another example which I stated earlier, that is a load attached to a spring, okay, will vibrate, okay, about its mean position. So if I pull this load slightly, what happens? This will execute the two oscillation, that is back and forth oscillations, that is to and fro motion. So this is another example for oscillatory motion. So that is vibration of a mass attached to a spring. So this is another example for oscillatory motion or oscillation. So as I said earlier, what are the conditions, okay, for the body to oscillate? Conditions for body to execute oscillation. Okay, so there are few conditions. Okay, so where if that particular conditions are satisfied, then the body will execute the oscillation, that is oscillatory motion. So the first condition is the body must have inertia to keep it moving across the midpoint of its path. Okay, so this is the first condition. Okay, we will discuss one by one. And there must be some restoring force. There must be some restoring force to accelerate towards the midpoint. So this is the second condition. And the third condition is the frictional force. The frictional force acting on the body must be minimum. So these are the three conditions that must be satisfied for the body to execute oscillatory motions or oscillations. See, first condition is the body must have inertia to keep it moving across the midpoint of its path. See, what do you mean by inertia? Inertia is nothing but the property of the body to continue in its state of motion or to continue in its state of rest. That is opposition for the change. If inertia is not there, what happens? It cannot go on moving around its midpoint. So that is why we say that the body must be having some inertia to continue in its state of motion. So that is the important, one of the important criteria for the body to execute oscillation. Now what is that restoring force? To accelerate towards the midpoint. See, for example, if I consider a simple pendulum, okay, so what do you mean by simple pendulum? We have already studied. Suppose, okay, if you are dragging this particular simple pendulum bob, okay, towards your right, okay, now you will leave this. Due to inertia, it keeps on moving towards its midpoint. So after once it is reaching to midpoint, again it should move back to the other end also, correct? it should come to this end also. This is to and this is fro motion. So this is what we call it as the to motion, okay, and this is what we call it as the fro motion, correct. So now in order to take back again to this position via its mean position, there must be some force which is dragging towards its initial position, or to initiate the flow motion we need some restoring force, correct, to restore to its original position. So that is what we call it as the restoring force, that is been necessary to accelerate towards its midpoint, okay. So if it is at this point, it should accelerate towards its midpoint. So for that, something must be pulling towards the mean position. So that force is nothing but your restoring force, okay. Why frictional force should be minimum? So frictional force should be minimum because if air resistance is there, it will object the motion of the this bob towards the mean position due to frictional force. Frictional force will be always acting in a direction opposite to the motion of the bodies, okay. So therefore that must be minimum. If it is minimum, then we can see some amplitudes of oscillations, okay. So now these are the conditions of the body to execute oscillatory motion. So now we shall see what do you mean by time period, frequency, and different terms related to our oscillation. So before going to that, so we have to make one important note. So what is that important note means? See, all oscillatory motions are periodic motion. Remember this very carefully. All periodic, all oscillatory motions are periodic, but all periodic motions are not oscillatory. Understood? So we can see here in the oscillatory motion, I can calculate what is the time period taken by the bob to go from here and again to come back to here. That is what we call it as one oscillation. Okay, one to and from motion. How much time it take? It is time period t. Correct? But again after the time period, the motion get repeated itself. Correct? So which is the characteristic of the oscillatory motion. But in case of periodic motion also we calculate the time period of periodic motion. Okay. But all the oscillations or all the oscillatory motions are periodic, but all periodic motions are not oscillatory. So this point we have to remember. All oscillatory motions are periodic. So all the oscillations whatever you measure, it has certain time period for one oscillation. Okay, there is a meaning for this. All oscillatory motions are periodic, but all periodic motion may not be oscillatory. Clear? Now let us understand what do you mean by time period of oscillation. So these are the terms or definitions related to the oscillatory motions. So first one is your time period. Okay, so time period can be defined as the smallest time interval after which the motion is repeated is called time period of oscillation. So the smallest time interval after which the motion is repeated is what we call it as the time period of oscillation. So next is frequency of oscillation. Frequency is nothing but the number of oscillations produced in 1 second. So this is what we call it as the frequency of AC. So time period is usually represented by the symbol capital T, and frequency is represented by the symbol small f. Okay. The relation between time period and frequency is T is equal to 1 by f is equal to 1 by time period. So this is the relation between frequency and the time period. And this SI units are a little bit important. SI unit is second, okay, and SI unit is hertz. So this is what we call it as the time period and frequency of a oscillatory motion. Hope you have understood. So now let's move on to the next definition or the term. So next we have amplitude. What do you mean by amplitude? So amplitude is nothing but the maximum displacement from its mean position. Okay, understood? The maximum displacement from its mean position is what we call it as the amplitude, and it is represented by symbol A. Okay, so this amplitude may be positive or negative. Okay, so what do you mean by mean position? Means it is nothing but your rest position. So for example, let us consider the simple pendulum. Here this is your inextensible string and this is the bob which is attached to the simple pendulum, and the entire thing is tied to a rigid support. So now at this point the bob will be at rest, correct? So this is what we call it as the mean position. Mean position is also sometimes termed as the rest position. Okay, now so this point, if I allow the simple pendulum to oscillate, okay, so it will produce to and fro motion, correct? So these 2 points, or one is x and another is y. So these 2 points are called as the extreme positions. It is called as extreme positions. Okay, now what happens? Okay, so this is your maximum point that the bob can reach. After reaching this point, again it should go back to its mean position. It will be driving towards this, correct? So this is your maximum displacement, correct? So this is what we call it as an amplitude. So the maximum displacement from its rest position or mean position. So this is what we call it as the amplitude of the oscillation. Okay, so this sometimes what happens, it will be positive and sometimes it will be negative. So this you are seeing in a horizontal plane. If you look at the vertical plane, what happens if this is the mean position? Okay, so if the particle at here, it is at rest. If it is going to this position, so this is your amplitude now. So if I consider the vertical axis like this, so here what happens, this is the positive axis and this side will be your negative axis, you know this, correct? So if the, if it is executing simple, oscillatory motion, okay, so it again come back to downwards. Okay, so here we have your negative. So this is what we mean by positive and negative for an amplitude. See, if you are, repeat it once again. If there is an oscillation or oscillatory motion taking place in the horizontal plane, then we can consider this side as minus A. Okay, why? Because if I consider here the axis, okay, so this side is your negative and this side is your positive, right? So here it is plus A and this side it is minus A. If you consider the vertical plane, so your displacement will be along y axis, vertical axis. So therefore what happens, this is your rest position and this is your extreme position. Okay, so this is positive A. Why? Because the displacement is along the positive y axis, and here this is your minus A. Why? Because the displacement is towards the negative axis. That's why we say the amplitude may be, what is that, positive or it may be negative. Clear? So hope you have understood what do you mean by periodic motion, what do you mean by oscillatory motion, what are the conditions for oscillatory motion, and what are the few little bit definitions that we have studied until now. So I hope you have understood. Now let us come back to one of the important type of motion. So that is what we call it as the simple harmonic motion. So simply we will abbreviate this as in a short form as SHM. So many of the students ask why it is simple harmonic motion. Okay, so this will make you understand in this session. Okay, so we know that what do you mean by motion, correct? So if there is a change in the position of the object with certain time, then we say that the body is said to be in motion, correct? So you know what do you mean by motion? That is nothing but if the position of the body changes with respect to time, then that is what we call it as the motion. Okay, now if the motion of the object, can be expressed in terms of sine or cosine functions. Okay, so we know that we will be using variables x or y to represent the motion, that is displacement. Okay, so if you are expressing this displacement, that is the motion of the object, in terms of sine or cosine function, which are nothing but known as harmonic functions. Okay, which are called harmonic functions. Then the motion is said to be harmonic motion. Understood? So harmonic means it should vary continuously, or it should decrease continuously, or it should increase continuously. That is what we call it as a harmonic function. We know that sinusoidal wave and cosine waves, correct? So if you are able to express the motion of the object in terms of sine or cosine function, then we call that as a harmonic function. Then why the word simple came into effect? So if this harmonic expression can be expressed in the simplest known types of periodic motion, right? So if we express the harmonic motion in terms of simple known types of periodic motion, then that is called as simple harmonic motion. So if we express the harmonic functions in terms of simple known type of periodic motion, that is, what is the simplest type of periodic motion? That is nothing but uniform circular motion. So this is nothing but the simplest form of motion in which is periodic, correct? Right? So therefore that is what we call it as the, if you are able to express this simple harmonic motion, what is that? The harmonic motion in terms of simple known type of periodic motion, that is nothing but your uniform circular motion. So now we call this as, hence it is called as simple harmonic motion. Simple harmonic motion. We will repeat it once again. If any motion, okay, so if any motion is taking place, either you will represent the motion of the body in terms of x or y, correct? So if you are able to express this x or y, okay, in terms of sine function or in terms of cosine function, so which are nothing but, these two are nothing but harmonic functions. Okay, so if you are able to express any motion in terms of sine or cosine, so then such type of motion is said to be harmonic motion. Okay, now if you are able to express the harmonic motion in the simplest form of periodic motion, then that becomes your simple harmonic motion. Understood? So this is what we call it as a simple harmonic motion to understand. But actually the definition of simple harmonic motion will be stated as follows. See, the definition for the simple harmonic motion is, a particle is said to execute simple harmonic motion if it moves to and fro about a fixed mean position, about a fixed point, under the action of restoring force. Then so what should it should execute means, for a simple harmonic motion, the first condition is, that is, the body, there must be some restoring force which is acting always towards the mean position. So that is, the restoring force must be directed towards the mean position, So this is the first condition, okay, and the restoring force must be always directly proportional to its displacement from its mean position. That is, this restoring force, okay, magnitude, I am speaking about magnitude of restoring force, okay, must be directly proportional to the displacement from its mean position. So that is, the restoring force must be directly proportional to its displacement. Here we can include a negative sign. So the negative sign indicates that restoring force is always directed towards its mean position, So this is the definition for the simple harmonic motion. So definition is, a particle is said to execute simple harmonic motion if it is moving to and fro about a fixed point under the action of restoring force. So what are the conditions that to be satisfied for the simple harmonic motion to execute is, first one is, the restoring force must be directed towards the mean position, and the restoring force, that is the magnitude of the restoring force, must be directly proportional to the displacement from its mean position. So that is, we can write F is directly proportional to minus x. Okay, so the negative sign here, it indicates that the restoring force is always directed towards its mean position. So if they ask for the definition for simple harmonic motion,